All right, welcome back to the second trig lesson. We are going to be looking at finding missing angles using the trig ratios. Okay, so last time we were looking for trig ratios given the angle. Today we are doing the opposite. Okay, we are given the trig ratios and we want to find the missing angles. Now, before we do that, we are going to review a little bit of what we did last time. So recall, we can simply put these into calculator and it spits out a value. Now recall what that means is, again, SOHCAHTOA, right? SOHCAHTOA. So I'll do it for the first one. For sine 78, it means that we have a triangle with angle 78 degrees. Maybe steeper than that. So probably something like this. Okay, here's 78 degrees. And here's the opposite side. Here's the hypotenuse side. I don't know why I wrote an O there. Hypotenuse side. And sine 78 supposedly should spit out a value that is the ratio between the opposite side and the hypotenuse side. In this case, again, it should be less than 1 because hypotenuse side is the longest, but it should be somewhat close to 1. So let's put that into calculator and see what we get. We should get 0.978. Remember, make sure your calculator is in the degree mode, okay? So 0.978. And if you do the same thing for the next two, you should get 0.5 here, and tangent 35 gives you 0.700. Okay, so again, sine is opposite of hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent side. Okay, so that's, again, given the angles, we can find the ratio of the sides. Now, sometimes we'll be given the value of the ratio, and we can use this ratio to find the angle, the acute angle in the right triangle. And how do we do that? Well, just like when we solve like linear equations, 3x equals to 12, to solve for x, we divide it by 3, okay? So to solve for the angle, or in this case, to solve for the x, we do the inverse, because 3x means 3 times x. So to solve for x, we divide it by 3. So to find the angle given the ratio, instead of taking sine, cosine, and tangent, we are going to take the inverse. So take the inverse trig ratios. Okay, so inverse sine, inverse cosine, and inverse tangent, and so on. Okay, so I'll show you here. So you can see clearly, I'll rewrite this as sine theta, right? Here's the angle theta. We don't know what it is, but we know the ratio between the opposite side and hypotenuse side is 0.0523. So to solve angle theta, what you have to do is you're taking the inverse. Okay, so that's the notation for it. Sine -1, so inverse sine of 0.0523. Okay, and that will tell you what the angle is. Okay, now to do this, what you have to do is you got to look for the button on the top left of your calculator. Usually it's a shift button, or sometimes some other calculator has it as a second function. So you press that shift or second button first, and then you press sine, and on the screen it should show sine -1, right? So inverse sine, and then you simply put 0.0523 into your calculator, and you should get 3 degrees. We are rounding to the nearest degree, so sine of 3 degrees. Okay, so this actually gives you 3 on the calculator. Okay, so it's sine of 3 degrees. Similarly here, if you're solving for angle theta, so cosine theta is equal to 0.978. Again, this means the ratio between the adjacent side and hypotenuse side is 0.978. And in this case, we take the inverse cosine of 0.978. Again, that means you press the shift or second button, and then cos, and then put 0.978 into calculator. You should get 12 degrees. Okay, so I'll let you finish the rest and then see if you can get the same answer as I will show you in a bit. This one you should get 32 degrees. Again, theta is going to be inverse tangent of 0.625. And this one, this is 89 degrees. Okay, so again, theta equals, you should write this out every single time, 29, and in this case is the inverse sine of 0.454. This is 27 degrees. And finally, this is going to be 8 degrees. 8? Hold on a second. I don't think that's right. 2.6 degrees. So 3 degrees. I missed a last 9 here. So actually it matters. Okay, first time I use 0.99 and it gives me 8 degrees. But if it's 0.999, it's actually 3 degrees. Okay, so be careful with your, make sure you include every single decimal point. Okay, that gives you 3 degrees. All right, so that's the first example. The second example, again, this time we don't have the ratio that's given to us. We need to set up the equation ourselves first. Okay, so you can see these first questions, you can see the equation is actually kind of set up for us already. We just need to take the inverse. But for the second example, we actually need to find the equation first. Okay, so again, here is the right triangle. SOHCAHTOA only works for right triangles. Here's angle K. So the first step, you guessed it, we need to name the sides. Okay, so here is the opposite side. This is the hypotenuse side, and that's the adjacent side. Now, in this case, opposite side and hypotenuse side is given. So O and H, okay, they are given. So guess what? We are going to use sine ratio because we know both opposite and hypotenuse, okay? So we're going to write sine of the angle K, sinc, is equal to the opposite side over hypotenuse side. Okay, so sine of K is equal to 3 out of 8. So to solve for angle K, we simply take the inverse sine of 3 over 8. And then we put that into a calculator. Okay, now when you do this, make sure you put 3 out of 8 in brackets. Okay, otherwise you are going to get a different answer. We are going to round to the nearest tenth, so this is going to be 22.0 degrees. Okay, now for M, you don't have to rename the sides using angle M, because again, in a triangle, we know they are 180 degrees. So to solve for angle M, we already know that triangle is 180 degrees, angle N, which is the right angle, so 90 degrees, and we just solve for K, which is 22 degrees. So if you just subtract them, you should get 68.0 degrees. Okay. All right. Why don't you try part B? Again, the first step is to name the sides. Okay, so I'll let you do that. Pause the video, and I'll show you the answer in a bit. Okay, so here's angle theta. This is the opposite side. This is the hypotenuse, and therefore this is the adjacent. This time, opposite and adjacent is given to us, so we should use tangent, okay, because it's TOA. Okay, tangent, use it because opposite and adjacents are given to us. So tangent theta is equal to opposite over adjacent. Therefore, to solve for angle theta, you simply take the inverse tangent of 9 out of 13. Okay, and if you put this into calculator, inverse tangent, 9 out of 13, in degree mode, you should get to the nearest tenth, 34.7 degrees. And again, to solve for angle alpha, you simply take 180 minus the 90 degrees, that's the right angle, and angle theta. And this will give us 55.3. Okay. Hopefully that makes sense to you. Again, the first step you should do is to name the sides, check what's given to us, and use the appropriate trig ratio, either sine, cosine, or tangent. Again, depending on what's given to us. In this case, adjacent, opposite, those are the sides that's given to us. We have to use tangent. In this case, hypotenuse and opposite, therefore we have to use sine. Okay, because those are the two sides that's given to us. Okay, moving on. We are going to look at some word problems. Okay, so to solve any OR problems, the first step that you should do is to draw the diagram, okay? So here it says a support cable is anchored to the ground 5 meters away from the base of a telephone pole. So here's the telephone pole. Here's the cable anchored to the ground, and that is 5 meters away from the base of the pole. So here's 90 degrees, and the cable is 19 meters long, okay? It is attached to the attached near the top of the pole. Okay, so fine, here is the pole. What angle to the nearest degree does the cable make with the pole? So we're looking for this angle right here, right? Because we're looking for the angle that's between the cable and the pole. Okay, so that's the angle. So here's angle theta. Let's name the sides. Here is the opposite side, and here is the hypotenuse side. Okay, so just like the previous example, we are given opposite and hypotenuse. Therefore, we have to use sine because it's so katoa, right? So sine theta, again, every time after sine, cosine, or tangent, it has to have an angle attached to it. So sine theta is opposite over hypotenuse. To solve for angle theta, you simply take the inverse of it. So inverse sine of 5 out of 19. Make sure to put 5 out of 19 in brackets. This you should get to the nearest degree, so 15 degrees. Okay. Okay, hopefully that makes sense to you. Moving on to the next example. But again, anytime you do OR problems, draw the diagram first, okay? So here we go. It says an observer is sitting on a dock watching a float plane in Vancouver Harbor. At a certain time, the plane is 300 meters above the water and 430 meters from the observer. Determine the angle of elevation. Okay, so this is new. I'll explain to you in a second of what that means. Of the plane, measure from the observer to the nearest degree. Okay. All right, so here is a plane. I'm terrible at drawing, so here's the plane. That is 300 meters above water. And it is 430 meters away from the observer. Okay, so observer is sitting on a dock. So here is the observer. Okay, so here's the observer sitting down. I know that's standing up, but that's okay. 430 meters away from the observer. So here is 430 meters. Okay, so the plane, here's the plane, which is 430 meters away from the observer. Not a horizontal distance. Okay, so that's the distance. Determine the angle of elevation. Okay, so angle of elevation simply means, actually here it says, the angle of elevation of an object is the angle between the horizontal and the line of sight of the observer, okay? So here is the observer, here is the horizontal line, and this is the line of sight to the object. So the angle in between is what we call the angle of elevation. Or sometimes we call this the angle of inclination. Okay, it's the same thing. So here's angle theta, and that's what we are solving for. So again, to solve for theta, you gotta name the sides. Opposite, hypotenuse. So again, sine is the one we need to use. Sine theta is equal to opposite over hypotenuse. To solve for angle theta, you simply take the inverse trig ratio, in this case inverse sine, of 300 over 430. Okay, so put this into a calculator, and you will get, we are rounding to the nearest degree, so 44 degrees. Okay, so I've done 2 examples, so why don't you try the last one? Well, I'll draw the diagram, you know what, because it says angle of depression. You know what, try to draw a diagram first on your own, and I'll explain to you what angle of depression is in a second. Okay, so here's this, a person is in an observation deck 30 meters above the ground, so here is 30 meters, and here is a deck, sort of, I guess, and the person is right here. She sees her friend standing 120 meters away from the base of the tower. So here is 100. Okay, this diagram clearly is not drawn to scale. That's 120 meters. Find the angle of depression between the girl and her friend. So this is the girl, and here's the friend. We're looking for the angle of depression. So earlier we talked about angle of elevation is between the horizontal line and the line of sight. Guess what? Angle of depression is the same thing, except this one is looking downwards, right? Angle of elevation means you're looking up. Angle of depression means you're looking down. So here's the horizontal line, and here's a line of sight to the girl. We are actually solving for this angle right here, and here's angle theta. Okay. Now to solve for angle theta here, there are two different ways. I will tell you this. Actually, I'll do it this way. Okay, so we know this is 90 degrees, right? This is 90 degrees because that's horizontal and that's vertical. Therefore, that makes this 90 degrees. So to solve for angle theta, we could technically, well, I guess, if you just kind of draw this triangle this way, this 120, you can move it up here. That makes it 120. This 30, you can move it over here, and that's 30. Now, instead of solving for the triangle that we have, you can solve the blue triangle instead. Okay, you can solve this triangle instead. It's really the same thing, right? You can just shift the triangle or the sides around. Okay, so there you go. We can solve this right triangle instead. So here's angle theta. Now to name the sides, here we go. Opposite side. This time, this is the adjacent side because here is the hypotenuse. So we are given opposite and adjacent, so we have to use tangent. Okay, so tangent theta, recall, is opposite over hypotenuse. Opposite over adjacent. So 30 over 120. So to solve for theta, you simply take the inverse tangent of that ratio, and then just put that into a calculator. So inverse tangent, bracket, 30 out of 120, or 3 out of 12, or a quarter. Whichever way you do it, it's the same thing. Does it say how many decimal places we round to? No. Let's just say 14 degrees. Round to the nearest degree. It's 14.04. So let's just say 14 degrees. Okay, so that's how you can use the trig ratio to solve for the angle. Okay, remember, you have to take the inverse because that's just the, if you take one step forward to go back, you simply take one step back. So taking the inverse is like taking the step backwards. Okay, and yeah, use SOHCAHTOA based on, or choose one of those based on what information that's given to us. Okay, so that will wrap this lesson up. Try some practice questions and let me know if you have any questions. Okay, good luck.